Hello. Okay, complex numbers are numbers of the form a plus b times I. So it's what you get when you have an a real number called the real part and pair it with b times I, the imaginary part. Okay, so this is the general form of a complex number, a plus bi. So let's say we have 2 minus 3 times I. So this is written in standard complex form, and you can actually graph these in the complex plane. It's sort of like the x and y axis. Let me draw it here. There's the vertical axis. Try to draw it as neat as I can. And here's the horizontal axis. Okay, the horizontal axis is the real part. So I'm going to put the symbol for the real numbers here. And the vertical axis is the imaginary axis. So it's a lot like the xy axis. Okay, I'm going to number it out to 3. 1, 2, 3. 1, 2, 3, and 1, 2, 3. So if you want to graph 2 minus 3i in the complex plane, you can really write it as an ordered pair. So the first number is the real part, which is 2. And the second number is just the coefficient of, it's b, the coefficient of I, which is negative 3. So you have to include the minus sign. Okay, so the point 2, negative 3 is right here. Only you wouldn't use parentheses. You'd say this is the complex number 2 minus 3i. Here's another example. Let's say we just have an imaginary number, I. Where is I? Okay, well that would be, since there's no real part, you should put 0 because it's 0 plus I, and then you have 1 because the coefficient of I is 1. So we put a dot right here, okay, and that's where the number I is, the point for I is. Okay, one last thing. So the magnitude of a complex number is written with these sort of absolute value bars right here. The magnitude of a complex number is how far it is from the origin. And this will be important later on when you study complex form or trigonometric forms of real numbers and so forth. Okay, I didn't do that very well, but it's the distance from 0. So this is going to be the magnitude of a plus bi, and it's just really sort of the distance formula. It's going to be the square root of a squared plus b squared. So let's find the magnitude of 2 minus 3i. In other words, how far is the point 2 minus 3i from the origin? Well, that's going to be the square root of 2 squared plus, and we have to square negative 3, so we're going to put parentheses around it, 3 squared. This equals the square root of 4 plus 9, which is the square root of 13. So that's the magnitude of 2 minus 3i. This is the square root of 13. For I, we really don't need to use this formula because we can see that the magnitude of I is 1. Okay, that's it.